Now next is Venn diagram. Now Venn diagram basically it means what? Representation of some data, because we are on the chapter of the sets, so definitely we are going with the sets, representation of sets and all the things. So I am just telling you representation of some data. Data can be in a mathematical form, in the form of a question, means in any other form, okay, for especially for the reasoning part also, okay. So when we are representing a data in the pictorial form, in the visualization form, we being a human, what happens that strucks in our mind more. We never forget when we are looking towards a picture. Now suppose I am saying you, when you were small kid, not I am, when you were small kid, what your teacher used to say to you, that this is a mango, M stands for mango and mango is like this. So shape of a mango strucks in your mind, if your eyes are closed or not. If I am asking you, just close your eyes, draw a picture of mango, of course you are going to draw it, you are going to sketch it, okay. So pictorial form is very important in mathematics also. Venn diagrams means what? To represent a set in the pictorial form, okay. So let's move for the definition part first. Now the relationship between sets operation on sets can be represented operation on sets can be represented by means of a diagrams, which are called Venn diagram. I told you chapter is set, so Venn diagram will be related with sets only, okay. Now Venn diagram facilitate understanding of set operations. Now there can be a confusion that why sir has written a word that is set operation, okay. So first of all, it was my duty to just define what Venn diagram is, and after that we are going to do set operations. Few questions, few topics, few terms based on the set operations, okay. In Venn diagram, the universal set that is U or X, capital U or capital X, okay. Sorry. In Venn diagram, the universal set is represented by the interior of a rectangle, and its subsets as the interior of closed curves within the rectangle. Is it clear? Now I will just go once again through it, but let me describe you first one thing. Now let U is equal to set of natural numbers such that 1 is less than is equal to, let n be the natural number, less than is equal to 11. Okay, or we can just write it set of natural numbers. Let it be U set of natural numbers, a big set. A is equal to, elements of A are 2, 4, 6, 8, 10. Elements of B, set B are, not elements, set B. What set B is? Set of prime numbers lying between 0 and 12. Let it be a statement. Now how Venn diagram is represented? Just look here. Now we will be representing, writing here U means universal set. This U means set of all the natural numbers. Okay, then we can mention here two sets. This is set A, this is B. Now I have just joined two sets, not joined, I have intersected two sets. Okay, why? Just look here. Now can I write here 2, 4, 6, 8 and 10. Okay, set A 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Set B, set of prime numbers lying between 0 and 12. So 2, 3, 5, 7, 11. So now if I am just showing you only this figure is shown to you, then can you think that what the sets are, what set A and set B is? Why the intersected part? Because 2 is common in both the sets. Even prime number is 2, 2 is also here. So you can have an idea that what set A is, looking not towards the question, not towards the example, not towards the definition, only towards this figure. You will be say, sir, we can. Elements of set A are 2, 4, 6, 8 and 10, and elements of set B are 2, 3, 5, 7 and 11. So if my question is what are the elements of set A and B, you can easily tell me. That is what representation of set operations now, or a sets in the Venn diagrams.